Good afternoon, class. We are looking at practice test number 3, module 3, covering chapters 6 and 7. Here's chapter 7, estimating parameters and determining sample sizes. We want to answer the following: true or false? The confidence interval estimate of the population mean is constructed around the sample mean. The answer is correct because CI, short for the confidence interval, has the formula X bar plus minus E, and E is Z alpha over 2 sigma over square root of N, where sigma of X bar is sigma over square root of N. Again, all of these formulas are provided to you, and for you. So you want to make sure you understand the concept and when to use it and how. Estimation means assigning values to a population parameter based on the value of a sample statistic. So, for example, here X bar would be a sample statistic. And this creates an interval of X minus E to X plus E. The confidence level is denoted by 1 minus alpha times 100%. Normally, whatever the choice of alpha is, for example, alpha is 5%, then the confidence interval or confidence level for that matter would be 95%. The maximum error, also known as margin of error, of the estimate for mu based on known sigma is E equals Z alpha over 2 sigma over square root of N. In other words, E, which has this value, is known as the error or maximum error or margin of error. The parameters of a T distribution is, there's only one, and that's degrees of freedom. And degrees of freedom, by the way, normally is calculated as N minus 1, depending on the type of distribution that you are dealing with. What criteria are required to apply the T distribution to make a confidence interval for mu? The sample must be a simple random sample. Either the sample is from a normally distributed population, or N is large. How large? Larger than or equal to 30. So either they mention that it's normally distributed, then sample size is not important, otherwise it has to be very large. Population standard deviation, meaning sigma is missing, is unknown. That's when we use the T distribution, also known as studentized or student T distribution. Could somebody read this for us, please? Anyone? I appreciate it. Okay, we don't have any readers today, huh? Sample statistic is used as a point estimate, which is a specific numerical value estimate of a parameter, or a point estimate is a single value or point used to approximate the population parameter. Example, the sample proportion P hat is the best point estimate of the population proportion P. confidence interval. We can use a point estimate to construct a confidence interval estimate of the true value of a population parameter. Find the value for T for a T distribution with sample size of 20 and a confidence level of 95%. Again, we can always use technology, but if you're using the table, I want to quickly show you how this thing is going to work out. Number one, in this case, this is 95%, this area. Let me just write that. So this portion right in the middle, we have 95% of the data. The rest, 1 minus that, would be the total tails, the two tails. So 95% is smack right in the middle. So if this is 95%, this is 5% divided by 2. This is 5% divided by 2, which makes it 0.025, 0.025 for this case. Makes this one. So 5% would be the total tails divided by 2. All right, here's how the table works. When you look up the T distribution table, you have a table like this. It says T distribution critical T value. On the left side or the left column, you have degrees of freedom. And since there wasn't enough room, I went to 5, then to 18, then to more, because I'm interested in number 20. And degrees of freedom is n minus 1. For this question, degrees of freedom is 19. So the very first thing you do is to locate number 19. And then above here, find whatever you have to find here. In two tails, the area is 5% or 0.05. In one tail is 0.025. So take a look. Here, area in one tail is 0.025. Area in two tails is 2.05. Now, if you put these two together, we end up right here. And so T has a negative value here and a positive value here, because T, just like the Z, is 0 right in the middle. Remember the Z score of 0 here, right? Corresponding to the mu. Therefore, you put this number with a plus minus. There are two values for it. We're going to look at a similar question. Now, the sample size is 30. We want to find the T for T distribution with the sample size of 30 and a confidence level of 90%. So we are changing the numbers. So what happens is, now this is 90%. And this is 10% divided by 2, or 0.1 divided by 2, or 0.05. And so now, degrees of freedom is n minus 1. So 30 minus 1 makes it 29. So you locate 29 in this column. First, you locate the 29 in this column. And then up here, you locate the area in one tail is 0.05, in two tails is 0.1. In one tail, this is area in one tail, 0.05, in two tails, 0.1. Put these two together right here. And because it's a confidence interval, here's the negative value, here's the positive value, you have plus minus 1.69. If you were to use technology, and that's fine, you can do that, but it's important to understand that degrees of freedom, for example, is n-1, so on and so forth. So you can go with the t-distribution, find the t-score, second plus var, second variables, and inverse t, and you put the left area and degrees of freedom. So here's what we do here. For example, for this one, I'm not going to do both. For this one, the left area is 0.05, degrees of freedom is 29, and the number it gives you negative 1.699 with a lot more decimals, and we need to know it's referring to this value. But we also need this value, that's why we have the two of it. Also, this is a t-distribution calculator online. This is another calculator online. And in case you use Excel, it also uses T inverse. So instead of inverse T, it uses T inverse. You can also look it up. Find the critical chi-square value for 20 degrees of freedom when the area to the left is a 0.01. Well, first let's see what's the chi-square distribution. The chi-square distribution must be used to calculate confidence intervals for variances and standard deviations. The chi-square variable is similar to the t variable in that its distribution is a family of curves based on the number of degrees of freedom. The symbol for chi-square is chi-square, Greek letter chi, pronounced chi. A chi-square variable cannot be negative when the distributions are skewed to the right. So here's just a table that you see. You may or may not have this that indicates the shaded area is equal to chi-squared of alpha. And in this case, degrees of freedom is given as 20. Area to the left, I put A sub L, area to the left is 0.01. But I hope you see what this graph is telling us. It says we need degrees of freedom and area to the right if we want to use the table. That's what we need to do. Therefore, if the area to the left for this one, so if we were to do the drawing just for the sake of argument, or this would be, again, I'm going to erase it afterwards. It will, first of all, it starts from 0 and it's skewed. So this area is 0.01. That's the idea. But you need the area to the right. You need this area. And this represents total probability of 1. So 1 minus 0.01 makes area to the right as 0.99. So if the area to the left is 0.01, the area to the right is the complementary event, 1 minus that. So what we are going to do, we are going to go to the chi-square table. On the left column, just like the t-distribution, we see degrees of freedom, and we are looking for 20. So I'm going to add more to that. Again, there's not enough room to see the rest of them. So here's number 20. And at top, alpha, we need the area to the right. We need the area to the right. In this case, we said the area to the right is 0.99. So right here. So this is number 20. Right here, we find 9.99. And you put them together. So the answer is 8.260. And again, I can't emphasize this enough. It's never negative. We are dealing with the chi-square. Okay, so chi-squared of the left is 0.01. The L, the left area is 0.01, equals chi-squared for the right area is 0.99 is equal to 8.260. I hope you will understand what I'm trying to say. The left area was given as 0.01. We used the right. If you look at the second part, find the critical chi-square value for n equals 30. So since n is 30, you need degrees of freedom, which is n minus 1, and it makes it 29. When the area to the right is 0.9. So the very first thing is to find the degrees of freedom, and the area to the right is given. You don't have to do anything. So again, since we didn't have enough room, I'm going to add this, okay, such that we find number 29. And then over here, we are looking for this number, 0.9. So we have these two numbers, 29 as the degrees of freedom, 0.9 as the area to the right, and they come together, they give us this answer. So chi-squared of the right now, which is equal to just 0.9, or just write chi-squared of 0.9. Okay, I just wanted to emphasize that I already have that. It's this number. And if you use technology, for example, you can use this calculator online. That's fine. You can come up with the answer, but you need to know the degrees of freedom and so on. A statistician is interested in estimating at a 95% confidence level the mean number of houses sold per month by all real estate agents in a large city. It is known that the population standard deviation is 1.9. How large a sample should be taken so that the estimate is within 0.65 of the population? So as always, when we are given a question, it's essentially a word problem. So what is given? Well, 95% confidence level. So we want 95% confidence interval. Population standard deviation, that means sigma. Population, pay attention to population. We use Greek letters. If it was sample, we would say S. Population standard deviation is 1.9. How large a sample should be taken so that the estimate is within 0.65? E is 0.65. So that's the given information. We want 95% confidence interval. Population standard deviation is 1.9. E is 0.65. So let's look at the formulas that you already have access to. Confidence interval, or the means would be X bar plus minus E. Because sigma is given, we are going to go with the Z, and sigma of X bar is sigma over square root of N. E is the alpha over 2 sigma over square root of N. And if you were to calculate the N, if you do the cross product, you can calculate it in this manner. We will get to that in a moment. So if you square this, is Z squared sigma squared over E squared. So if you square this one, E squared equals Z squared sigma squared over N. And if you do the cross product, you can. So I hope you see that from this, you can create this formula. It's just a cross product. So let's use that. Now, we want 95% confidence interval, and it's one of those common values. So as you can see from here, the confidence interval of 95% for Z, it's minus 1.96 here, 1.96 here, because we have a 5% divided by 2 on each side for each tail, and Z is 1.96. So in this formula, we have everything. Z is missing, and Z is 1.96. Again, you can pick it up from the table or technology. Now plug in. When you plug in, class, whatever it gives you, I want you to know that you have to answer it as a whole number. So this must be rounded up. First and foremost, this is the minimum number we need. So if it's 32.1 or 32.8, makes no difference. You round up. You always round up. So it has been rounded up. Find the 95% confidence interval if the mean of such sample size is 3.4. So basically what we are saying is that this is X bar, and use this formula. That's the concept. So X bar is given as 3.4. We are interested in X bar plus minus E, or X bar minus E less than mu less than X bar plus E. Please understand, sometimes they give it to you in this format, sometimes they give it to you in this format. So basically 3.4, we are going to subtract and add this number E. That's why it's important to write the given. So subtract 0.65 from the number X bar 3.4, and also add, and that is the confidence interval. So we have a confidence of 95%, or with 95% confident, we are sure that the true mean is somewhere between 2.75 and 4.05. A random sample of 20 female members of a health club showed that they spend on average 4.5 hours per week during physical exercise, with standard deviation of 0.75 hours. Assume the time spent on exercise for all female members is approximately normally distributed. What is the value of the point estimate of the population mean, so on and so forth? So first, again, let's go back to the question, read it again, and write the information symbolically. So first and foremost, we are dealing with ND, normal distribution. Second, N, the sample size of 20. Average is 4.5. Now, is this X bar or mu? Please understand, this goes back to those 20 subjects, 20 female members. Therefore, it's X bar. Those 20 female members showed that they spent this much. So this is X bar. And for the same people, the standard deviation is 0.75. So that makes it S. So pay attention to the notation. This is X bar. That means a sample. This is S. And if we don't recognize that, the calculation will be completely off. So the point estimate for any population parameter, it's appropriate sample statistic. So for a population mean, the answer is sample mean, or X bar. And we know it to be 4.5. So the point estimate of mu is X bar, which is 4.5 hours. We want to come up with the 98% confidence interval for the mean time spent on physical exercise of all such females. Now let's make up a 98% confidence interval. So if we are dealing with a 98% confidence interval, how do we deal with that? First, the formula is X bar plus minus E, just as before. However, instead of sigma of X bar, we're going to use SX bar because it's a sample, because sigma is missing. So S over square root of N, and E is T alpha over 2 times S over square root of N instead of Z alpha over 2. And instead of sigma, we are using S. So I hope you see what's happening. When we don't have the population, we use this formula. So that's important to understand. So we're dealing with 98% confidence interval, which makes alpha of 0.02. So if we were to look at this concept, because graph really helps, we have 98% here. And then this is 2% divided by 2, or 0.02 divided by 2. So each tail is 0.01. Half of this, because there are two tails, okay? So we are going to use N equals 20, makes degrees of freedom 19. Now we can use the table or technology. And T becomes The negative value is for this one, the positive value is for this one, plus minus 2.539. So you find this either using technology or a table. And now X bar plus minus E. In other words, X bar minus E less than mu, less than X bar plus E. This is the interval of interest. Sometimes we show it this way, sometimes we show it this way. These two mean the same thing, class. And we are using this one, okay? Again, you do have the formula available to you. All right, so let's first calculate the value of E, replace this with 2.539. The reason it has a plus minus is because minus goes with this one, plus goes with this one, okay? So for this one, we just use the plus. S 0.75 over square root of n20. So the fact that you wrote the given, it really helps calculating this easily. So make sure you write your given symbolic. Now, so 2.539 times 0.75 over the square root of 20 using a calculator with a bunch of decimals gives us 0.4258. Now, going back to the X bar, which is 4.5, we're going to subtract this from it. We're going to also add to it because that's what we are looking for. We are looking for a 98% confidence interval. So subtract the number, add the number, and we end up with the following. So we are 98% confident that the true population mean is somewhere between these two numbers, 4.0742 and 4.9258. So we are 98% confident that this interval contains the mean time spent on physical exercises of all such females. If we were to use a technology, and we could, as long as we write the given, we write some formulas, and we show the steps, and then if we use that, we can go with the confidence interval or T interval. You go stats, test, T interval, and you enter a few pieces of information. For example, in this case, we go with T interval, stats. You can put the data, by the way, if you, that means you are given maybe 10, 20 pieces of data. In this case, 20, you have to use that. But since we are given X bar, 4.5, we're going to put that. S is 0.75, N is 20, and we are interested in 98% or 0.98 is the C level or confidence level or CL. And when we calculate it, look at the number it gives us, compare that to what we have here. 4.0742 versus 1, 4.9258 and versus 2.59. Here's the reason they are slightly different. Because when you use a TI, any technology, this is going to have more decimals. This is going to have more decimals. And that's why the numbers are slightly different. But that's how you calculate them. Again, as long as you show work, that's fine. Other 500 randomly selected adults, 300 said that they were in favor of the death penalty for a person convicted of murder. What is the value of the point estimate of the population proportion? As mentioned before, the point estimate of a population parameter is a sample statistic. So for the point estimate of P is P hat. And that's very straightforward. But let's write the given. So out of 500, so N is 500, 300 were in favor. So X is 300. So you're dealing with a BD, binomial distribution. You're dealing with a binomial distribution. N is 500, X is 300. And the point estimate of a P is P hat, which is X over N. And that gives us 0.6, X over N. Everything is justified with proper formulas, class. Everything is justified with proper formulas. What is the 95% confidence interval for the population proportion? Well, here's the formulas you have access to from the formula sheet. The confidence interval is P hat plus minus E. That means you start from P hat, and you go to the left and right by E amount. Mu of P hat is P, sigma of P hat is square root of PQ over N. Now, in a case like this, when we don't have P and Q, we estimate it with P hat Q hat over N. And therefore, E becomes Z alpha over 2 square root of P hat Q hat over N, because it's Z times sigma of P hat. And by the way, in the case of a proportion, which is using the binomial distribution, when we go with this route, we are approximating it with normal distribution, and we will always go to the Z. We never use a T because one approximation is bad enough. So with that being the case, we need to use this formula. And to use this formula, we have to calculate Q hat. We already have P hat. Q hat is 1 minus 0.6, which is 0.4. And of course, we need the Z. And as you may recall, for a 95%, we had the Z of plus minus 1.96. That's one of those common confidence intervals, 95%. So that should be fairly easy to remember. And Q hat is 1 minus P hat, giving us 0.4. So we're going to use 1.96 instead of that. P hat, we're going to use 0.6. Q hat, we're going to put 0.4. And for N, we are going to put 500. So let's plug in. See, all of this information we can easily plug in. Using a calculator with a bunch of decimals results in 0.0429. So now we have P hat plus minus E to calculate. So we have a P hat minus E and P hat plus E. So 0.6, subtract this number from it, 0.6, add this number to it. And it gives us P is between 0.5571 and 0.6429. And we have a 95% confidence with 95% confidence, or we are 95% confident that the true population proportion is somewhere between that. Now, if we were to use a calculator and any sort of a technology, in this case, the TI, we go to a stat, test, and then one prop, that means one proportion Z interval, and we put the information. So take a look. One proportion Z interval. X, it's asking for X, 300. It's asking for N, 500. It's asking for the confidence level. We want 95% or 0.95. And it'll give us the answer. By the way, it calculates the P hat, it uses the P hat and N equals 500 for us here. And when it calculates, if you look at this number versus this one, we have 0.5571. Over here is 0.557. If you do the rounding right here, 0 changes to 1. We have 0.6429, and it stops here if we drop the 4. Again, of course, you get more decimals and more precise answer with a calculator, because this number doesn't stop there. They use a lot more decimals there, as well as here for the Z. How large a sample is needed to be 99% confident that the margin of error is 0.025 for percentage of golfers that are left-handed, if we assume that 15% of the golfers are left-handed based on a previous study? So again, first and foremost, let's write the given first. So the confidence interval of 99%. Margin of error is E. Margin of error is E. So first, let's write that. Then understand what's happening. These formulas are given, and as I've mentioned before, from here, if you do the cross product and square it, you get to N. So we are interested in finding the value. How large a sample, that means find N. So we're going to use this formula. So what does this say? P hat is 0.15. And we are using this with 99%. P hat is 0.15. And for a 99% confidence interval, the values, the critical values are plus minus 2.575 if you look up a table. And by the way, that means this is 1% or 0.01 divided by 2, which makes it 0.005. So P hat is 0.15. That's what's given here. Since the confidence interval of 99% we are interested in, Z is 2.575. That's what we are going to use. In other words, in this formula, now we have the Z value. We have P hat. And of course, we need Q hat, which is quickly 1 minus that. So Q hat is 1 minus P hat, which makes it 0.85. So now in this formula, we have everything. We replace the Z with 2.575, P hat with 0.15, Q hat with 0.85, E with 0.025, and we square that. Okay. Remember, this gets squared, you use a calculator, and you get to this number. Again, you have to answer as a whole number. N is the sample size, how large of a sample. And when you look at this number, that means minimum we need this number. So if you go with 1,352, that's not good enough. You must round up, even if this number is 0.1. So if it's 1,352.1, you still round it up. Always round up. So we knew that this was given as 15%. P hat was 15%. But now, assume that we have no prior information. That means we don't know this class, suggesting a possible value for the sample proportion. We have no idea. When that happens, you go with the worst case scenario. If you use P hat and Q hat at 0.5, that is the worst case scenario when you don't know anything about that. And by the time you finish, the number N that you calculate here must be larger than this, and it is. If it's not, you've made a mistake somewhere. So as before, confidence interval is 99%, E is 0.025. So we're going to use the same formula, but P hat and Q hat are equal. If you sometimes they use 0.25 here because 0.5 times 0.5 is 0.25. So we use the same formula, and 0.5 times 0.5 again. You don't have to memorize that. It's important to know where it comes from, and that is this one is the product of a P hat, Q hat, of 0.5 times 0.5, which is 0.25. That's how they come up with that answer. And so you're going to plug in. Z is the same Z as the previous one. We had it here. So 2.575. E is the same as, so if you look at this one, everything is the same. These two numbers are changing. This is 0.5, this is 0.5. The product is 0.25. Put it into a calculator. And again, pay attention that this is 2,652.25. Doesn't matter what this number is, you must round up. So the answer is 2,653. That's why you got to pay attention to the rounding. Your answer will be wrong if you don't do this. You must round up. Always round up. Given n equals 30, x bar is 80.5, s is 4.6, and assume normal population, find 98% confidence interval for population variance and standard deviation. Normally we write the given, but it's given, it's already given symbolically. We don't have to write anything in that sense, okay? So we want to find the 98% confidence interval, and here's the formulas. Let me read this. Sigma squared is between n minus 1 s squared, chi squared of the right, less than n minus 1 s squared, chi squared of the left. This is not to the second power, it's chi squared is called. Normally, we don't care for the variance. Normally, we want the standard deviation. So we use this and we take a root of all sides. This is what we are normally interested in, which is the square root of the previous line. And so when you look at this, you see that n is given, so we have it. So 30 minus 1 or 29 here. S is given as a 4.6, we have it here. So over here, we have over here, but we don't have this two, which means all you have to do, use your table or any technology and find the chi-squared value for the 98% confidence interval. So here's the graph of a 98% confidence interval. And remember, it's all skewed to the right and it's all positive. And so this area is a 0.02 divided by 2 or 0.01. That's the concept, okay? And the same thing here, 0.01. That's the first. Let me clean up the mess. So we have degrees of freedom is n minus 1 or 29. So in this column, we are looking for 29. That's why there was not enough room. So I have included the 29. So of course, there are more numbers here. So the left column, we're looking for 29. 98% confidence interval, 1 minus 0.98 makes it 0.02. Therefore, area to the right is 0.01 for chi-squared of the right. So take a look. This is 98%. This is 0.01. This is 0.01. So for this one, we don't have to do anything. Area to the right is given. But 29 and then 0.01, 29 and 0.01, you put them together, and that is the chi-squared of the right. This is chi-squared of the right, 49.588. Now, chi-squared of the left, we need the area to the right of it. As you see, the area to the left is 0.01. The rest of it, that means the complementary event, that means 1 minus that. That means 0.99 is the area to the right. For this, the area to the right is 0.99. So for the same degrees of freedom of 29, up here, look for 0.99. Put these two together, and this is the number you're looking for, 14.257. So 14.257 is the chi-squared of the left. Now, when we go back to this formula, we have everything we just plug in. So let's plug in. N minus 1 in both cases is 29. S squared in both cases is 4.6 squared. Chi-squared of the right, 49.588. Chi-squared of the left, 14.257. And I use the proper colors so we don't mix them up. Now you put it into a calculator. So sigma squared is between the two. So find 98% confidence interval for the population variance. This is the answer. And you're done for the variance part. For variance, this is the answer. For the standard deviation, just take a root. So this becomes sigma. Take a root of the left side, take a root of the right side. And this is the 98% confidence interval for the standard deviation. So we are 98% confident that the true standard deviation for the population is between these two numbers.